Hello. So what we're going to do today is we are going to talk about how to interpret geometric diagrams, right? So we've learned about points, lines, and planes, and a little bit of vocabulary that kind of goes with each of those. What we're going to do today is we're going to take a look at some slightly more complicated diagrams than maybe yesterday, right? Or whenever you watch the last one, I guess. And we're going to try and determine if some statements are true or false. So let's just jump right in. Right? Something I will say about these is that, with these statements, if the statement is false, as it mentions here, we want to change the underlined word in order to make the statement true, right? So it's not just, oh yeah, no, I don't see it, right? We also want to figure out, all right, what is the correct thing to say there? Right, so first off, we've got this diagram over on the right-hand side of the screen. It's got a plane, it's got some lines, it's got a bunch of points with labels on them. So this first statement is trying to tell us points D, G, and F are collinear. All right, so whenever you're working on any of these, it might seem like kind of a duh move to make, right? But you want to figure out where the heck these things are that the problem is talking about. So I'm looking at D, G, and F, right? And it's saying that those points are collinear. So remember that collinear means that they are all on the same line together, right? They line up. Co meaning, together, linear meaning line, hopefully makes sense, right? Something that's still in your brain from before. So if I'm looking at those 3 points, they all are on the same line in the diagram, right? So to say they're collinear would be true, right? No big deal there, right? True, done, cool. For points H, G, and D, right? So again, I'm going to start by identifying which ones those are, H, G, and D. What this is saying is that they are non-coplanar, right? So one of the things we need to worry about, right, is what the word coplanar means, right? Non at the front is just kind of a prefix that says like they're not, right? But coplanar is the real meat and potatoes of what we're talking about on this one. So just like collinear, right? Co means together, and planar is talking about being on the same plane. So this is saying that points H, G, and D are not on the same plane together. But in this case, that is false, right? I'm noticing that H, G, and D, save for any kind of weird geometric diagram magic that's going on that we can't see, right? They should all be on the same plane. So this one actually comes out to be false, right? And we need to now come up with a different word other than non-coplanar to talk about them. So if they weren't, if they weren't not on the same plane, then we could say that they are on the same plane, right? They are coplanar, right? That is something that we can replace that does make that statement true now, right? Let's try another one out. DF and IJ intersect at point D, right? So DF, this line here, and IJ, that line there, intersect at point D, right? So where they intersect. Oops, and actually I guess it's talking specifically about point D, so you would label that or highlight that one, I guess. So if I'm looking at those 2 lines that I just highlighted in yellow, and I look at where point D is in blue, something tells me they don't quite cross there, right? So this one also is going to come out as false, right? In order to correct it, right? It just seems like we have to change which point they cross at, right? So it's not D that they cross. Looks like it's point G, right? So that's how we would fix something like that one, right? Next one, points H, G, F, and K are non-coplanar, right? So whole bunch of points here. H, G, F, and K are non-coplanar. So again, non-coplanar means that they don't all fall on the same plane. If I'm looking at those 4 points that I just highlighted there, it does appear that that's true, right? K is just kind of floating off in space. It doesn't look like it's on that same plane that the other 3 are, right? So true, and that one's done. No big deal, right? The true ones are kind of nice because it's just like, all right, yeah, all right, we're done. All right. Last couple here. Oh, actually, there's more than I thought. DF is on the plane, right? So again, this one's talking about a line, right? Is it on the plane? I mean, again, it could be floating above it. I would never know. But as the diagram is drawn there, I have no reason to think it's not on the plane. So if it's on the plane, Yeah, that sounds about right. True. Right. For number 6, IJ is on the plane. Right, so again, we're going to just take a second and look at which one IJ is. Is that on the plane? All right, so think to yourself for a second. Think about what might be different about IJ versus DF, or what might be the same. All right, so if I'm looking at IJ, I'm noticing that there's this little piece here that's got a little bit of dash to it, and then there's these different chunks of line that are just kind of like hanging entirely off of the plane, right? So it doesn't appear that the entire line is on the plane. I would say that that one is false, right? As for what word to replace it with, right, that one can be a little bit tricky. So, I mentioned that it has that little dashed area there, right? So something we talked about last lesson when we were talking about points, lines, and planes in general is that when we have a line cross through the plane, we use a dashed line just like it is underneath G to represent it being kind of like behind the plane or like hidden by the plane itself, right? So instead of saying that IJ is on the plane, we might say that it is through. Oops, oh my goodness. It is through the plane. That worked a little better that time. Right. Whoa, down towards the bottom of the page there. Points I and J are non-collinear. Right, so again, identify what things we're talking about, I and J. For them to be non-collinear, that would mean that they can't be on the same line. However, we were just talking about the line IJ and it goes through the plane and all that. So that one's false, right? Think for a second, what word would we replace that with, right? They're not non-collinear, right? So if you said, oh yeah, then they're collinear. Oops, wow, this is really mad at me today. Sorry about that. Whew, just lines all over the place. Right? Then they are collinear, right? They're falling on the same line together. Right? You can zoom in a little bit again, make the diagram a little bigger. We have DF and point H. So DF is here, and point H are coplanar. So this might be kind of a weird one, right? If you're thinking back to the definitions that we did yesterday, coplanar was talking about 4 or more points that are all on the same plane, right? So you might be thinking, well, this is a line and a point. They can't be coplanar, right? That's just not how the definition works. So this is where it gets maybe a little bit tricky, right? Remember that when we're talking about a line, right, a line is just a ton of points, right? It's infinitely many points that all line up, right? So if I'm talking about the entire line DF and point H being coplanar, right? In this case, they look to be on the same plane. I would say that that is true, right? Oop, that's not a question mark. That's an exclamation point. So, that is true because, again, H is a point, and then every single little bit of the line DF is also a point. They're all on the same diagram together. Right. This next piece, we have IJ intersecting the plane at point F. So IJ, it's intersecting the plane. Ooh, at point F. Over there? That doesn't seem right. Right, you can probably tell this one's false, right? That is not where we're crossing the plane, right? The point where we are crossing the plane appears to be right there, right? It's that point where we go from solid line into dashed line, right? That's what's telling me that I'm kind of in front of the plane and then all of a sudden behind it. If you imagine like poking a pencil straight through a piece of paper, you can see the top of it, but you can't see the bottom of it because the paper's now in the way, right? So instead of saying intersecting at point F, we would intersect at point G. Right? That's all there is to these. And last but not least, for this diagram at least, we have that IJ and DF are perpendicular lines. Right? So this is something we haven't really talked too much about yet, right? That was what perpendicular lines are. So a little bit of a preview. Perpendicular lines are when you have two lines that cross each other and make a 90-degree angle, right? So usually when you have perpendicular lines, and let me just make a quick little sketch off to the side of here, right? If I had two lines that were like that, I still don't even know if they're perpendicular. I don't know if that angle is 90 degrees until put that little square mark in there, right? You may have seen that before. That does mean that that angle is a right angle and that it is 90 degrees, right? So if it doesn't have that, I can't tell if two lines are perpendicular, right? Even if they look like it, just like that, they're not perpendicular until I have that little marking in there, right? So as I'm looking at it, I don't see that little marking, right? So I cannot say that they are perpendicular lines. I'm going to have to say that that's false. As for what they are, right, there's a whole variety of things we could say, right? We could say that they are intersecting lines, right? They do cross each other. I could say that they are non-coplanar. Well, actually, can I say that? Not always, actually. Never mind. I think we might just want to say intersecting. My bad. Yeah, so they're just crossing each other. I don't know, what angle they're making when they cross, right? So I can't say they're perpendicular, but I can say that they intersect, right? Down here, it's asking you to create your own, right? Write one true and one false statement about the diagram, and then try to use one of those words that's down there in each of those statements, right? This is one where, I can't really guide you through exactly what to say because it's creating one on your own. If you come up with one that you want to double check and make sure is correct, please be sure to ask about it during class, right? Something I might say that is true about this diagram is I would say that points I, D, G, and H are non-coplanar, right? That would be a true statement. Something that might be false is saying that points H, F, and D are collinear, right? They are not on the same line. Right? So just something that's true, something that's false. Right? Let's take a look at a couple other diagrams. Ooh, so this one's got a whole bunch of lines crossing each other, right? Where those letters are, that is talking about these different points of intersection, right? Having the dots there is, kind of a formality. If they're not there, you're still talking about where they cross usually. So points D and A are collinear. I mean, they seem to be, right? If I'm looking at them, they seem to be on that same line there. That sounds pretty true to me. Points F, E, and C are non-collinear. Right, so points F, E, and C. F, E, C. It's saying that they're non-collinear. Right, so again, think to yourself, is that true or is that false? So what I'm seeing is that it seems to be false, right? They do seem to be on the same line. Right, so just like one that we took a look at on the last problem, on the last diagram that is, instead of calling them non-collinear, we could just simply call them, collinear. Right, easy fix. I didn't mean to erase all of that. I guess we are. All right, so what I'd like you to do is pause here, try out 14, 15, and 16 on your own, and then unpause when you think you got it, right? So hopefully you gave that a shot, right? If you still haven't, try it out, right? Worst case scenario is you're wrong and you can fix it when we go through it together, right? Not a bad thing. So DF and CE intersect at point D. So DF and CE intersect at point D. That doesn't seem to be true, right? So we're going to say that that's false, right? Where they do intersect appears to be down there by F, right? So I would just say switch that from D and switch it over to point F, right? That's all we're doing there. All right, next one up, DF and BE are parallel lines, right? So, again, I'm hoping you try these on your own. If this one gave you a little bit of a hassle, then it's all right because it's something we haven't fully talked about yet. You may remember parallel lines from a past math class. If you do, that's great, right? Parallel lines are two lines that are going in the exact same direction, and they will never, ever cross each other, right? They're never going to intersect, right? So the tricky thing about parallel lines is that you might be looking at those two. You might be saying like, oh yeah, no, they look pretty darn parallel to me, right? But parallel lines, just like perpendicular lines, need to have a specific type of marking on them in order to make them parallel, right? So it's like, oh yeah, I drew those two lines. They look pretty good, right? They seem to be parallel, but we don't 100% know that unless we have little markings like that showing that they're going the exact same direction, right? Instead of little things like that, they might be filled in arrows just like these, right? But as I'm looking at our diagram, we don't have that, right? So what we're going to have to do is we're going to have to unfortunately say that this is false. As far as what we would call them, right? In this case, we could say that they don't intersect with what's shown, right? There's a lot of different ways that we could talk about this, right? One thing that we can say for absolutely certain is we could call them coplanar, right? I could just draw a big old plane around all of this, right? And then all of a sudden, wow, look at that. They're all on the same plane, right? Might seem a little hand wavy, right? And maybe you're right, right? But that is something we could try to say here. It wouldn't hurt too much. All right, so if you had a little trouble with 15 again, that's okay. For 16, we have DF and AB intersect at point A. So DF and AB intersect at point A. Wow, that looks pretty correct, yeah, right? So I would say that that one is true. Right? Nothing to fix there. It's already working out just fine. Right? On this one, there's another create your own, right? So, I'd like you to at least give it a shot, right? Think about one true and one false statement about this diagram. Try to use one of those words it mentions, right? One more diagram to talk through, and then we are done with this lesson. Oh boy. Right? So points D, G, and B are coplanar. So points D, G, and B are coplanar. So this is definitely the most complicated diagram that we've come across so far. Right? So it's got one plane kind of going up and down and another plane going side to side, and they cross each other right there. So what I'm seeing is that B, D, and G, right? Well, point G is definitely on that like up and down plane R. If I think about points B and D, those are also on plane R, right? They're still on that part where it's going straight up and down. I would say that that one is true, right? Up next, we're saying that point F up there is on plane P, which is this one. And unfortunately, that doesn't seem to be the case, right? Point F is hanging up in the air compared to plane P in the yellow there. So what could we change that to? Point F is actually on plane fancy looking R, right? Plane R is the one that we're on when we're on that kind of up and down piece, right? So that's all we need to do. We just change it to the correct plane that it's on. Right? Plane P and plane R intersect at BA, right? So this is one where, if you're a little, if you're having a little bit of trouble visualizing this in your head, what I would suggest you do is take your two hands, right, and kind of, make the Spock symbol. I don't know if you know that, like the live long and prosper symbol from Star Trek. And then just kind of interlock your hands, right? There's going to be one that's kind of facing up and down, the other one's facing side to side. That's kind of like what we've got going on here, right? So if you imagine that your hands are these two planes, right, they do intersect at a whole bunch of points, right? It's right where all your fingers are touching the opposite hand. In this problem here, in this diagram, this is the place that those planes intersect each other, right? They cross right there, all right? So thankfully, we don't have to fix anything in that because it's true. So that's pretty nice. All right, what I'd like you to do for these last ones, try them out, right? Try out these last 5, right? And unpause when you think you got it. We'll talk through it together, but give them a shot on your own first. So hopefully you did that, right? For 21, we're saying that points B, D, and E are collinear. I'm sorry to say that doesn't seem to be the case, right? Those are not all on the same line. You'd have to make a triangle to get to every single one of those, right? However, they all do seem to be on the same plane, P. So instead of calling them collinear, we could call them coplanar, right? And that would work out just fine. For 22, it's saying that point G is on plane R. That one there sure seems like it to me, right? Point G is just hanging out on plane R right there, right? So we just say that's true, and we move right along. Point E is on plane P. So E is on plane P. Sure is, right? Point E, plane P. Cool. Again, another one where it's just, it is true. And then we move along, not too bad. After that, we've got points D, F, and G are non-coplanar. Right? So this one, again, might seem a little tricky, right? We know that F and G are on the same plane because they're definitely on that same area where it's shaded in the same way. And then point D is actually on both planes, right? It's right where they intersect, right? So it's on both planes at the same time. So these are actually on the same plane. That means that calling them non-coplanar would be false, right? And again, easy fix to that. Instead of calling them non-coplanar, we just say that they are coplanar. Cool, that's all. Last but not least, another name for plane R, that one going up and down, is plane CBE. All right, so this is something we haven't done quite as much of or at all through this second lesson here. But remember that another way you can name a plane is by 3 non-collinear points on it, right? So CBE is an okay way to name a plane. What we're trying to figure out is if it's another name for plane R. So what I'm noticing is that C and E aren't even anywhere on that yellow shaded in plane R. Right? So unfortunately, what we'd have to say here is that this is false. Right? Those are not another name for plane R. So plane R is the part we need to change. So instead of being another name for plane R, would you hopefully agree with me that it's another name for plane P, right? All 3 of those points are on plane P. Right? And again, it's fancy looking letter P. Good enough. Right? And again, that's all we're doing, right? We're analyzing these diagrams. We're taking a look for these specific pieces that they mention. And then we're just saying, like, all right, does that word match up with what I'm seeing, right? Are they collinear, all together on the same line? Are they non-coplanar, hanging out on different planes, right? So that's really what we're trying to get at here. Right? So that's actually it for this one. So if you have any questions, be sure to ask about it, and I will see you next time. Bye.